Welcome, my dear students. Today I am going to discuss about simple harmonic motion, that is oscillations chapter. Some of the problems which are asked in NEET previous year questions. Let us discuss about that. For that, the first question is, here he has given an equation and he is asking us to find out what is the time period and what is an amplitude for that. Now, let us take this equation and compare this equation with a general equation. What is the general equation? Here you can write x equal to a sine omega t plus phi. Okay, so directly amplitude, you are getting directly amplitude. Just in the place of amplitude, what is present? As it is in meters, you have to consider 5 meters. So this is 5 meters present here. But how are we going to find out the time period? What is the method to find out the time period? See, in the place of omega, what is present here? So just write omega in the place of omega, where omega can be taken as 2 pi by capital T. What is present here? Pi is present in the place of omega. Therefore, pi gets cancelled. This implies that time period is going to be 2 seconds. So we got time period, we got amplitude also. Therefore, the B option is going to be the correct answer for this. Now, let us go for the next problem, my dear friends. So, in this next problem, he is asking identify the function which represents the non-periodic motion. Non-periodic motion. Whenever you are going to represent a periodic motion, you should remember one thing, that it should be either represented with sine or cos, trigonometric functions. If there is no sine, if there is no cos, that means it is not going to be a periodic function. And there is one function which is written in the form of exponential form. Remaining all are written in the form of sine and cos. Therefore, the B option is the correct answer because it is a non-periodic function. Now, here, if you want to find out the third question, identify the function which represents the periodic motion. Okay, so what is a periodic motion? I just told you. If any trigonometric function, it is represented with sine and cos, it is called as a periodic function. So there is only one function, and therefore the correct option is this one. Now let us go for the next problem here. So he is asking us to find out what is the phase difference between displacement and acceleration. So for that, you just write displacement, which is nothing but a sine omega t. You will just differentiate this a single time with respect to time. Then you are going to get the velocity dx by dt. Okay. So here, if you differentiate this one, a sine omega t is going to become cos omega t. And if you differentiate omega t once again, you are going to get. Now, you find out what is an acceleration. Differentiating velocity with respect to time gives you an acceleration here. So therefore, here if you differentiate this one, you are just writing a omega like that only. Cos omega t, if you differentiate, you are going to get minus sine omega t. And omega t, if you differentiate again, omega, one more omega you are getting. So just make it square here. So if you observe here, what is the difference between this one and this one? One minus is extra here. Here sine omega t, here also sine omega t, here minus is extra. So what is the phase difference between these two? You just simply write acceleration is nothing but a omega square. Instead of sine omega t, this minus sign can be written as sine omega t plus pi. So now if you want to remove this minus sign, you just write sine omega t plus pi. That's it. So minus sign is getting removed, getting this equation. So if you compare these two, here both are positive now. And the phase difference is extra pi is coming in acceleration. Therefore, your answer is pi here. My dear students, let's see the next question here. The distance covered by a particle undergoing simple harmonic motion for one time period. If you are going to consider a simple pendulum, okay, so how many times it oscillates to and fro? Just see here now. It starts from the mean position, goes to another extreme position, comes to again mean position, goes to another extreme position, and again comes to the same mean position. That means here during the process, it travels from mean position to extreme position, that is amplitude. Again goes from extreme to mean position, it's going to be single, another amplitude. Again mean to extreme, another amplitude. Again extreme to mean, another amplitude. Therefore, for one oscillation, for one time period, it travels 4 times. There is 4 amplitude. There is 4 times of an amplitude. That's it. Now let us go for the next problem. Here, what is an average velocity of a particle executing simple harmonic motion in a complete vibration. Let us discuss about that now. Just see. So here, for example, you are going to take the same simple pendulum. This simple pendulum starts from the mean position. This is a mean position and this is an extreme position, another extreme position. It starts from the mean position and goes to another extreme position. Again comes to mean position, goes to another extreme position, again comes to mean position. Therefore, from starting point is this one and the ending point is also the same. The displacement traveled from starting to ending is nothing but zero. There is no displacement during this process. Therefore, the velocity which is said to be average velocity is nothing but total displacement by total time. Whereas total displacement traveled during this process is zero. Therefore, average velocity is also going to be zero. Your answer is this one. That's it.